I am Fran, developer, maintainer at OpenZeppelin, and have been here for quite a few years already. So that's me. So I'm just going to start sharing my screen, which if that sounds okay. Cool. So we're here today to talk about upgradable contracts and sort of what's new in that domain. We recently released this new kind of proxy called UUPS Proxy, and we're going to be talking about that a little. So as I said, I'm Fran, I'm with OpenZeppelin, and we work to protect this open decentralized economy built on blockchain. To that end, we have a suite of services and products focused around security and reliability that cover all aspects of development and deployment and operations of a decentralized application in this new economy. So we have from an auditing service where we have a highly skilled team of security researchers that make sure that the code does what the developer intended. We have the OpenZeppelin Contracts library, which I'm sure most of you know and has existed for a long time in the Ethereum space and contains many very useful contracts, well, some of which we're going to talk about today. And there is also the Defender platform, which allows projects to manage their operations on their projects once they have gone to production. So focusing on contracts today, as I said, it's a smart contract library, contains many things from token standards, security components, governance, which is soon going to grow, access control, which was the workshop that I talked about over a month ago, and also an entire upgradability solution, which is the focus of today. And that consists of some proxy contracts, a whole variant of all of the contracts that I just mentioned for upgradability, and also some advanced utilities to help you deploy these upgradable contracts securely. So the outline for today's talk is going to be divided in two sections. We're first going to discuss some theory. We're going to build up to this UUPS proxy pattern, trying to do that from first principles. And we're going to compare that with the transparent proxy pattern that has existed for longer now. And we're going to see how they compare. And then we're going to move on to the practice section and see how we can put this theory into practice and using OpenZeppelin tools, deploy these proxies and write these upgradable contracts and do that safely. So onto the theory part first. As all of these talks, unfortunately, we're going to start with a very brief explanation of what the proxy pattern is. But this time is going to be lightning fast. And this is basically it. This is the proxy pattern. The user, instead of interacting with your contract, with your business logic, is going to instead be interacting with a proxy. And this proxy is then going to delegate to the implementation contract, which is the one that is going to host all of this business logic. This pattern, just like this by itself, is not particularly interesting. It becomes interesting when the contract on the implementation side can be replaced by new versions, and this is what we call an upgrade. So let's look a little bit at how this works under the hood. A contract on Ethereum, if you didn't know, consists of these several components, right? It'll have some code, it'll have some memory while it executes, and it's also going to have storage. And storage is very important because it is persistent, right? It's going to persist across all executions. And among other things, in this storage is where we're going to keep the implementation address. So in the diagram that I showed before, where the proxy delegates is going to be kept in a location in storage, and proxy is going to retrieve that for every function that it needs to process. In order to implement these upgrades, there needs to be a way to change the value that is stored here in this implementation place in the storage. And so that is going to be, during today's talk, this upgrade to function that is the function that you can invoke on your system in order to change and upgrade it. And this is going to be quite a sensitive operation, of course, because this implementation storage location is obviously quite critical. It's like a critical configuration parameter of your system. And so we're also going to want to protect it in some way. And that's why we're going to be talking about this admin concept. We are generally going to designate an admin that is going to be the sole responsible and have the only one with the ability to touch this storage location and change it. So this upgrade function, in the drawing that we saw before, we have two contracts, right? We have the proxy and we have the implementation. So we can ask ourselves the question, in which side do we put this upgrade function? And the answer is not necessarily obvious. We can put it in both sides. And in fact, this choice is what's going to give us both options that we're going to be talking about today. If we put the upgrade function on the proxy side, we're going to get the transparent proxy pattern, which, don't worry, we're going to talk about in a little bit. If we put the upgrade function on the implementation side, that is going to get us the UUPS pattern. So first of all, let's do a refresh on what the transparent proxy is and why we are now talking about the UUPS proxy after all of these years. So like we said, in this transparent proxy pattern, the proxy is not only able to delegate calls from users to this implementation contract, it's also going to contain the logic to upgrade itself. So it's going to contain this upgrade to function. Now, there is a kind of security problem that comes from this that has been documented before, and these are two very cool articles that I encourage you to search afterwards if you want to know more detail. But the problem is basically that this upgrade function can clash with something that is on the implementation side. And that can be used to build some elaborate attacks that can, compromise the security of your system. So the transparent proxy, being vulnerable to this, needs to put together something to mitigate that. And the way that the transparent proxy pattern mitigates that is by showing it having sort of two different aspects of itself that it can show depending on who calls it. So if the admin calls in the proxy, the proxy is going to show its admin interface, right? Which is mostly the upgrade function that we've been talking about. And the admin is going to be able to do all of these things. Instead, if someone that isn't the admin, so any normal user, calls into the proxy is then going to delegate that function call, whatever it is, over to the implementation. So this is some complexity that you may or may not be familiar with. This complexity on the user side is normally abstracted away, but what we call this proxy admin contract. When you deploy a transparent proxy, normally you're also going to get with it, together with it, this admin contract that is going to be the only admin. So unless you go through this contract, everyone else is a user. And so no one other than this contract sees this admin interface. So this complexity is normally hidden away. But at the level of the proxy, this decision still has to be made, right? Based on the caller, what interface am I going to present? What am I going to show this caller in terms of what they can do with the contract? So what is the issue with this? The admin, just as the implementation, is going to be kept in the storage of the proxy. And the problem with this is that storage is actually one of the most expensive things that you can do in a contract. Running code, relatively cheap. Accessing and writing to memory, relatively cheap. But storage is really the most expensive thing. By the way, if you're ever optimizing the gas costs of your contract, storage accesses, reads and writes are the thing that you will want to pay the most attention to. So this if storage is so expensive, why does this pattern work in this way, right? The problem is that when every time that a user calls into the proxy, you need to check, is this user, is this caller the admin? And so you need to fetch the admin from storage, incurring the cost of that storage access, compare it, and then most likely it's not going to be the admin. And so then you fetch the implementation and you do the delegation. So it's like 2 storage accesses there. At the very beginning, when with this proxy pattern was released, this wasn't that much of a problem. Accessing storage wasn't really that expensive, but through the subsequent network upgrades that Ethereum has been going through, this has become more and more expensive. So first, with the Istanbul network upgrade, the cost of reading from storage quadrupled, and more recently in the Berlin upgrade, it more than doubled. So this Berlin upgrade was earlier this year, and that is what kind of made us go back and reevaluate the choice that we had been looking at before. Where do we want to put the upgrade function? And is there any way that we can make this very high overhead of using a proxy smaller? So the other choice is we put the upgrade function on the implementation side. And this is what we're calling UUPS, which is a name that was coined in this EIP 1822, which basically documented this pattern. So we're going to look at that now and see what it looks like. Like we said, this upgrade function is now on the implementation side. And it doesn't matter if it's the user or if it is the admin, everything that goes through the proxy just gets delegated as is over to the implementation. So we no longer have this overhead of having to fetch the admin on every call. And that is what gets us this reduction in the overhead that we were looking for. Now, for some people, it may seem a little counterintuitive. I certainly find it interesting. But how is it that the upgrade function on the implementation side can, as a consequence, change the way that the proxy behaves, right? Because they are kind of different contracts, and especially the implementation is sort of downstream. So how can it go up and change the way that the proxy behaves? The reason that it can do that is because of the delegate call EVM feature, which is what enables this delegation. The proxy delegates to the implementation, not using a normal function call, but this special function call, which is called delegate call, that what it does is kind of this. Instead of treating them as separate contracts, each with its own memory storage code, the storage is shared between the two during this call. So when the implementation runs this upgrade, what it does is it goes into storage and it changes the storage location pointing to the implementation to some other value. So this is persisted, and the next time that the proxy runs, it's going to find this new implementation and going to have been effectively upgraded, right? So what are the drawbacks in this pattern? Or is it all, rainbows? No, it's not. I would say the main drawback here is that it adds complexity on the implementation side. This upgrade function could potentially be complex, and it's adding some attack surface, right? It's adding more code that you need to worry about across, your development lifecycle. Not only that, but this function needs to be included in every version upgrade that you do, right? So, because imagine what happens if at some point you forget to include it in your version, I don't know, 20. You forget to include it, and suddenly you have killed the upgradability mechanism. Your upgradable proxy is no longer upgradable. So that is kind of a big risk because it's an irreparable mistake that you can make. And it's a problem that the transparent proxy doesn't have because the upgrade mechanism is built into the proxy itself, and there is no way to remove it accidentally, especially. So, the whole motivation for this is reducing the overhead, reducing the costs. So let's take a look at some of the costs around this to get an idea. When you deploy a transparent proxy, there's two numbers that we have to look at here. The first one is the cost of the proxy itself, and it's going to cost about 740,000 gas, which is quite a bit. And on top of that, like we said, normally when you deploy a transparent proxy, you do it together with a proxy admin contract that costs on top of that another 480K. So at today's gas prices, which are actually a little higher than they've been in the past month, this would be around 100 USD. That's the only number sort of that I'm going to give, but to give an idea of how the others compare. On the other hand, the UUPS proxy is a much simpler proxy, right? It only knows how to delegate. It doesn't know how to do anything else, doesn't care who the caller is. So it's much smaller, and deploying this proxy costs 390,000. Now, on the other hand, we now need to include this upgrade function in the implementation contract. And in fact, we need to do that for every new version that we publish. And this is this additional cost that we see right here. So based on these two numbers, there is not really a clear winner here. So we're not saying here that one of them is necessarily, 100% better than the other, but these are numbers that you need to consider and think about in order to make a choice. But UUPS certainly gives you more flexibility, in the future when you want to make some changes that we are going to discuss in a little bit. But more importantly, UUPS has less runtime overhead, right? This was sort of the whole goal, because the runtime overhead, the cost, it's what the user pays in the end, right? When the user goes and does an ERC20 transfer, they are going to be paying some overhead because you're using a proxy, and you may want to reduce that overhead as much as possible, not even as a courtesy, but because you want your users to sort of be happy with the contract that you've built. And the runtime overhead of using UUPS is certainly smaller than using Transparent. And to put these numbers into perspective, if this proxy or like upgradable contract was, say, an ERC20 token, the savings that you would get from using UUPS are about 5% of a transfer. So if that gives you a perspective on the sort of savings that we're looking at here. There's other cool things about UUPS, which is that the upgrade function, since it's now included in the implementation contract, can itself be upgraded, right? In the transparent proxy, the upgrade is sort of fixed in the proxy. You can't touch it, and it comes given with this access control mechanism, which is the admin with this quirky behavior. But in UUPS, you can customize that in any way that you want. You can say, I want to use an owner. You can say, I want to use some sort of, built-in voting. Or you can say, I only want to allow upgrades the first Monday of every month or something. Or you can do other, maybe more useful things like putting in a time lock. All of this is stuff that you can customize in the UUPS pattern that you can't do in the transparent proxy. So those are all of the things that why it's a little interesting, we think. So that concludes the theory part. Hopefully that wasn't too heavy. But now we're going to move on to the practice. And here we're going to be using, as I said, all of the OpenZeppelin tools that we have, starting with the upgradable contracts. If you know the OpenZeppelin Contracts library, it is these smart contracts which are not suitable for use with upgradability. Among other things, they have constructors. And constructors are no good when you have an upgradable contract. And I'm not going to go into detail on that, but you can look at some of the resources that I'm going to share later if you want to know why that's the case. So the upgradable contracts have their own package. This is the name of the package on NPM that we can install. And from this package, we're going to use the UUPS upgradable contract that implements the pattern that we've seen today. And on top of that, to add the access control mechanism that we just mentioned, we need to customize, right? We're going to use the normal Ownable. Then once we have built our upgradable contract, we're going to use the upgrades plugins. In this case, we're going to use the Hardhat version to deploy the contract that we wrote. And that's going to give us very important security checks to make sure we don't make any common mistakes with upgradable contracts. And it's going to give us some utilities for deployment, because since it is, the proxy and the implementation, and you need to orchestrate these things. And in the transparent proxy, it's even more complexity. These tools automate all of that for you. So we are going to do a live coding thing now. I don't know if we shared the repo link, but you can follow along there if you want. I'm going to assume that I'm now sharing my desktop. Otherwise, let me know. So I've set up a very small project here. We're just going to do a silly little contract. It's a Hardhat project. I'm using just two plugins, the Hardhat Ethers plugin to interact with contract factories, and so on, and our own OpenZeppelin upgrades plugin that is going to give us all of these security checks and utilities. So to get started, we are going to go and use the wizard, which I hope you are all familiar with. That is a tool that allows us very easily to put together contracts using OpenZeppelin Contracts. And we're just going to build an ERC20 token here. Just going to give it a silly name and some initial supply. And I'm now going to copy this to the clipboard and paste it in my contract right here. I'm going to get rid of this now. Once we have this contract, I have a very small test set up that should run. It just grabs the contract, deploys an instance, and checks that the name is what we said we configured just now in the wizard. So this is a normal deployment, right? It's not an upgradable deployment. So we are going to make it an upgradable deployment by using the upgrades plugins. Since we configured it in our Hardhat config, it's now going to be here in our Hardhat environment, this upgrades object. And deploy proxy is what we use instead of the built-in deploy function. We use this deploy proxy with the contract to get an upgradable deployment. So now this is going to go and try to deploy a proxy. However, we are going to see that it's not possible. Okay, like I mentioned, the plugin is doing some security checks in the background, and it's telling us a couple of problems that there are. So our contract, the Mars contract, has a constructor, and the ERC20 contract that we are using, the dependency, also has a constructor. So like we said, we can't use the contract package. We need to use the upgradable variant of that. And every contract in here has this upgradable suffix to let you know that it's upgradable, and so that it doesn't clash with the traditional OpenZeppelin contract. So instead of that, we use ERC20 upgradable here. Now, our own contract Mars has a constructor. This solves the second problem right here. But our own Mars contract now has a constructor. So we're going to turn that into this initialize function. This is going to allow us to deploy proxies. So this is going to be a public function, and very important, we need to protect this function, right? Imagine if we left this function open, anyone would be able to come and mint for themselves this supply. So that would be a big problem. And the way that we work around that is by using this initializer modifier that will only allow this function to run exactly once. So we run it when we deploy the proxy, do the prement that we wanted, and no one else will be able to call it afterwards. This initializer modifier comes from the initializable contract that is also in the package. It is in the proxy utils directory. And lastly, this is constructor syntax right here. We can't initialize ERC20 like that. When we are using the upgradable package, we need to do this. We need to call it in this funny way, but it is a standard way that the constructor is turned into an initializer function for all of these contracts. So with these small changes that we just made, we should now be able to deploy this upgradable contract with the test that we had written before. Right, so this is now deploying the implementation, right? It deploys the Mars contract. It then deploys a proxy admin, okay? Because we're gonna talk about that now, but this is still working in the transparent proxy mode. And then it deploys the proxy, connecting all of that together. All of that is done by this deploy proxy function call right here. So we're talking about UUPS proxies now. So we don't care about transparent proxies anymore, and we want to turn it into a UUPS deployment. The way that we do that with the plugins is by passing in a kind parameter. And here we can very easily specify that we want a UUPS deployment. So with that change, the plugin is now going to try to deploy a UUPS contract. Again, it's not going to work. Why? We should know this because of what we just discussed. Our Mars contract doesn't contain this upgrade function. So we wanted to do an upgradable contract, but if our implementation doesn't have this upgrade function in this UUPS model, it's not really an upgradable contract. So the plugin is detecting that and alerting you. And in fact, it's not allowing you to deploy the contract like that. It's telling us that we need to inherit UUPS upgradable to make it, to include the upgrade function. So it is giving us the import path right here. And we're just gonna put it in there and make it upgradable. Inheriting this contract adds the upgrade to function to our implementation contract right here. But that's not exactly enough. And we will see when we try to run the test, we get a compiler error that we are missing the implementation for this authorize upgrade function. And this is a function that is defined by UUPS upgradable in a virtual way. So it forces you to write it yourself. And what this does is it implements the customizations that we just discussed, right? So we are saying that we want this contract to be upgradable, but unlike the transparent proxy pattern, there is no admin built in here. So we need to explicitly say how we want to authorize this upgrade. And for this example, we're just going to use the standard Ownable contract. So we're just going to make it only owner. And for this, we need now to inherit Ownable. So now our contract is now UUPS, it's ownable, and the owner can upgrade. So with all of that, this now should pass. Good. So again, the test deploy proxy, we are requesting a UUPS proxy deployment, and it's working fine now. So that is all that we need to do to deploy a UUPS proxy using the upgrades plugins. Let's take a quick look now at how it works if we ever wanna, well, the idea is we will want to upgrade this contract. So let's quickly make a Mars v2. And we're gonna do this inheriting right here. If you are new to upgradable contracts, this may be new to you, but this is kind of our way of saying the v2 is just going to extend the v1, and we're going to add on top of that without removing anything that we had before. So we're just going to add this pure function and return a string. going back to our test, the way that this is going to work now is in the upgrades plugin, we can now use the upgrade proxy function. We can pass as an argument the proxy that we just deployed, so the contract instance that we got from deploying the proxy before. And now we need to pass Mars v2. We need the contract factory, which I can uncomment up here. And this should now be upgrading to v2. But it's not interesting if we don't test it. So, so we're going to do a sanity check and check that we have the new version v2. Hopefully that works. Ownable. Oh, interesting. So something really interesting happened here, and it's one of the current downsides of the upgradable contracts that is going to be fixed very soon. So we inherited the ownable parent, right? But the upgradable variant of contracts doesn't have constructors, and instead it has initializer functions. And initializer functions are, you need to keep this in mind, are at this moment like second-hand citizens in the Solidity world. And unlike constructors, they are not called automatically, unfortunately. So what we need to do is manually initialize the ownable parent that we inherited. And now that should work. So since we weren't doing that, the owner variable wasn't being initialized. And by the time it tried to authorize by checking that the owner was calling the upgrade function, there was no owner to compare against. So that's why it was failing. This thing that we forgot right here is very important. And it's one of the reasons why you need to have an extensive test suite. Even though the Upgrades plugin checks for many errors, this one, it currently does not check, although it will soon, I promise. And hopefully that's going to be a much better world to live in. But now we've deployed our proxy. Initial version worked fine. And time would pass here. We would develop new features, get some new funding, and run and deploy a new version and do this upgrade. And this is the new version that we have here. So that's all for the upgrades plugins with regards to UUPS. We have a little more time left, so I want to also show other things that the upgrades plugins are capable of detecting for you to compensate for the initializer that was missing, that was not detected yet. So in future versions, you may want to add new variables, right? You may have this new parameter. Let's say we call it a fee. And we're going to be perfectly able to upgrade to this function. Now, suppose that to upgrade to this version, suppose that we have this new version, version 3, and we kind of made a mistake here. Instead of extending version 2, we are just extending the version 1. And so we want to add, I don't know, a tax now. So, and let's copy this one over. The tax now. And in our test, after upgrading to v2, we are gonna upgrade to v3, and this is now gonna be v3. If we try to run this, right, first upgrade to v2, and then from v2 upgrade to v3, we're missing the factory. we're going to get this error. This is an error that's coming from the upgrades plugin. At the moment that we try to run this upgrade from v2 to v3, it is running these security checks that I mentioned, and it detected that there was a change in the state variables, right? It's saying we renamed fee to tax, or we can make it more interesting. We can change that to a string. And similarly, it's going to say that we replaced fee with this other tax variable. And like I showed, in the slides, in the theory part of the talk, when the proxy and the implementation are sharing the storage space that they're using, right? And similarly, all of these versions, version 1, version 2, version 3, they're all sharing the same storage space. The way that Solidity allocates the storage locations is linearly. For every variable that you define, it's going to give you the next storage location. And so when we upgrade from v2 to v3, the fee and the tags are landing at the same location. And so if we upgrade from v2 to v3, we're going to be reading this ridiculous tax value that is going to be reading from the previous fee value. So the upgrade plugin is realizing that this is going to happen, that you're going to corrupt your storage in this way, and it doesn't allow you to upgrade with this incompatibility. So the fix for that is that we don't remove this variable, right? We just add a new one at the end, and then it should upgrade happily. Good. So this is really, it works for all kinds of types. That's actually kind of, we built that last year. If you have structs, if you have mappings, and the error messages are actually quite nice, I think. So they make for a pretty nice development experience to guide you through navigating through these errors that you may not be so familiar with. And yeah, we're going to talk about that later. So that is it for the practice part. Let's go back now to the slides. So I just want to show a couple of things now before finishing. Documentation, very important. We recently put together this page that concentrates all of the resources that we have around upgradability. So if you are new, or if you are looking for some piece of documentation and you don't know related to upgrades and you don't know where it is, because it's many different components in different places, so it can sometimes be hard to find. You can just come to this page, and there are many links to all of the different guides and articles and API docs that you may want to find. So documentation, very important. It's also very important to us. We know that the documentation site is not amazing, but we are actively working on improving many things. I want to show this really cool thing that we added recently, actually. In the API documentation for the contracts, you now have a direct link to the repo, because I know many of you really enjoy looking at the source code. And I mean, that's amazing that you do that. I think it's great. So now you can jump from the docs to the repo very easily. And not only that, you have the import statements that you need to use really handy with this copy button right here, that you can just copy and paste in your editor. As you can see, it's the vanilla, right? Not the upgradable one, but there's going to be a toggle here at some point so that you can choose either of the two. If you have any other feedback about the documentation, things that you would like to see changed, please reach out to us, because that would be really great for us to know and hear from what you think. Lastly, if you're using an upgradable contract, you have this really critical piece of your system that is the upgrades mechanism, and you will want to protect that. Your admin or your owner, it can't be just your random MetaMask key on your browser. It needs to be a multi-sig. It needs to be very secure. And our recommendation for that is to use our Defender platform to run your multi-sig, run your upgrades. You're going to get these really nice summaries of the upgrade that you want to run and all of its parameters and so on. Additionally, using this Defender admin interface, which is the interface to your project multi-sig, you're going to be able to change other parameters of your system, pause your contracts if there is an emergency, and so on. So it's free to sign up. Go check it out. And these are many links. A couple of other, we've been running these workshops. There have been a couple already that are relevant to upgrades. If you're interested in upgrades, if you're interested in learning more how you can combine upgrades and Defender to run your system, go check out the blog. There's a couple of workshops about that. Anyway, thank you very much. Hope you enjoy that, and we can move on to questions now.